Hi guys. Today we are going to discuss the 2024 chemistry paper, inorganic and electrochemistry question, the seventh question. Okay, without further ado, let's get into it. So if you look at this, given the diagram, and let's get straight to the question. Okay. So identify the anode and the cathode. So first of all, you have to remember this thing. Anodes. It's very important in every electrochemistry question. You will use it in every electrochemistry question. Anodes. That is, no matter what, the place or the electrode where oxidation takes place will be the anode. Period. Okay. So wherever oxidation takes place, that will be the anode. So that's how you have to recognize the anode. And obviously the next one, reduction, is cathode. But if you find anode, the other one is cathode. So it's not that anode oxidation nadagu. Oh, sorry, it's not that the place where it's not that in anode oxidation will happen. It is that oxidation happens. That place is anode. You have to come like this. Okay. So anodes. With that in mind, okay, we'll see where oxidation is happening. So what do we have here? MgCl2, magnesium chloride in liquid state. So what is the constituent in this? We have Mg2 plus and Cl minus. If we see the products, see these are the products, right? Bubbles. If we see the products, we get from magnesium 2 plus, Mg2 plus, we get magnesium. From Cl minus, we get Cl2. So we can very well notice that this is reduction. From plus 2 state, it's going to 0 state. So this is reduction. This is oxidation. From minus 1 state, it's going to 0 state. So this is oxidation. So the anode is graphite. Okay. Then the cathode would be platinum. So for the first question, we can say anode is graphite and cathode is platinum. Next up, they are asking the anodic half reaction and the cathodic half reaction. So if you take in the anode graphite, Cl minus, that's in the Cl2, it's converting to, sorry, Cl minus, that's in the MgCl2, that's being converted to Cl2 gas, right? So anodic half reaction would be 2Cl minus converts to Cl2. Oh, by the way, physical states are a must in physical questions. So electrochemistry also comes under physical question. If you do not put physical states, you won't get marks. Or best case scenario, they might deduct marks. But it's important to put physical states. So here 2Cl minus becomes Cl2 gas, liberating 2 electrons. Okay, this would be anodic half reaction. Now if we take cathode, right, in a cathode we get Mg2 plus, that's the in MgCl2 turns into magnesium. So here we get Mg2 plus liquid that gains 2 electron and reduces to Mg solid. No, Mg yeah, solid. This is cathodic half reaction. So that's the first question. Right. So second question, we are asking write the overall cell reaction. So in case overall cell reaction is basically the addition of both the half reactions. So anodic half reaction and cathodic half reaction. Sometimes in case if the electrons are not balanced, see in here and here, they are not the same, we'll have to multiply one of the equations and get it. But here, since both anodic half reaction and cathodic half reaction has 2 electrons, it's just easy. We can just add it together. So when we add it, the overall cell reaction would be MgCl2 liquid, because Mg2 plus and 2Cl minus, when we add them together, it's basically MgCl2. MgCl2 liquid turns into Mg solid and Cl2 gas. So this is the overall cell reaction. The electrons get cancelled out. So this side 2 electron, this side 2 electron, they get cancelled out. Right. So third question they are asking, explain the following. Third question they are asking, state the direction of electron flow through the external circuit as the cell operates. Okay, so one thing you should remember when doing electrochemistry question is anodes. No matter what oxidation happens, that place would be anode. Second thing you should remember is oil rig. Okay, this is also very important. This is not only in electrochemistry question, you might need it in chemical calculation or redox also. Basically, so oxidation means loss of electrons. Oxidation means loss of electrons, and reduction means gain of electrons. This is oil rig. So whenever, like, if you are confused, oxidation means what is that? So oxidation reduction has three definitions. So one is gaining of oxygen, that is oxidation. Losing of hydrogen is oxidation. Likewise for reduction, gaining of hydrogen is reduction, and losing of oxygen is oxidation. But other than that, loss of electrons is oxidation, gain of electrons is reduction. Okay. With that in mind, we can see they are asking the electron flow, right? So we know this is anode, right? This is anode, that is cathode. So what is happening here? Oxidation is happening here, right? Okay. So if what happens is, basically I'll explain the process. MgCl2 liquid, okay, the Cl minus within the MgCl2 that comes here, that gets oxidized and it loses 2 electrons. So we saw earlier, Cl minus becomes Cl2 gas, liberating or losing 2 electrons. That's oxidation. So those 2 electrons that gets lost here, they travel through this electrode. They come all this way and they come here. And then the magnesium 2 plus, it gains 2 electrons and reduces to magnesium, right? So magnesium 2 plus, so the Cl minus reduces 2 electrons, that comes here and then it's here. So the magnesium 2 plus goes there, grabs the electrons, it gains electron and oxidizes to magnesium. So it reduces to magnesium. So that is the process. What's the direction of electron flow through the outer circuit? Anode to cathode. Okay. So the answer is graphite to platinum electrodes. Don't write anode to cathode, that's correct, but the thing is, in electrochemistry question, always the electron flow is from anode to cathode. That's one thing. So if you write anode to cathode, it's better to write graphite to platinum electrodes, right? So that's the third one. Fourth one, explain the following. Molten MgCl2 liquid is used instead of MgCl2 solid. Why? Right. So the answer for this is when MgCl2, let's take MgCl2 is a solid precipitated. So it's MgCl2 solid. Right. So this MgCl2 in its solid state does not have any mobile ions, or we can say free moving ions or movable ions. Basically, the MgCl2 in solid state, anything when it's solid, we know the atoms are tightly bound together. So we would have studied in lower grades. So this is the atomic structure of something that's solid, closely packed and bound together. And if we have an atomic structure of something like a liquid, it will be kind of loose, like this. And of a gas would be very spacious, right? Solid, liquid, gas. So we know that. Then we know that when MgCl2 is in its solid state, it's tightly bound together. So there is no free ions or free moving ions that can conduct electricity. What is conduction of electricity? Moving ions. Ion, when they move from one place to another place, electricity is conducted. So can we use that as an electrolyte? No. Why can't we use that as electrolyte? Then it would conduct electricity. So the process won't take place. But MgCl2 fused or molten MgCl2 liquid, right? It has free moving ions. Why? Because in its liquid state, like I said. So Mg2 plus exists as Mg2 plus liquid. Cl minus exists as Cl minus liquid. But in this case, everything will be together as MgCl2. There won't be Mg2 plus or Cl minus. It won't be broken. When it's liquid, it would be broken. So electricity can be conducted. That is the reason why we don't use MgCl2 solid, but we use MgCl2 liquid. So since this is an explanation question, what we need to write is solid MgCl2 does not have free moving ions or mobile ions. Therefore, it cannot conduct electricity. Whereas fused or liquid MgCl2 has free moving ions. Hence, electricity can be conducted through it. That's why we use this instead of this. Right. Second one. Solution of MgCl2 aqueous cannot be used in this extraction process. Right. So what are they asking? They are asking why aren't we using MgCl2 aqueous? Right. The reason for this is there's a thing called electrode potential or standard reduction potential. That is this. This is called electrode potential, yes. But it is also called standard electrode potential. It's also called standard reduction potential. So what does that mean? So what it means is that it is this number that we have here. It signifies the ability of something to undergo reduction. For example, let's take two people. There's a guy, Ahmad, and another guy. Okay, Jack. Right. Ahmad and Jack are there. Let's say this Ahmad's reduction potential, standard reduction potential, is plus 5. And Jack's standard reduction potential is plus 3. Okay, it's 5 volts, 3 volts. What this essentially means is that Ahmad has more potential to undergo reduction. So if we are like, okay, Ahmad, Jack, who wants to reduce first? Ahmad would come running to reduce first. Jack would be kind of hesitant. That is what this means. So in this case, so who is more positive? That person wants to reduce. In this case, minus 2.37 is the reduction potential of Mg2 plus liquid to give Mg solid. Minus 0.63 volt is the reduction potential of water, H2O liquid, to turn into H2 gas. Who is more positive? This one or this one? Obviously this one. This is more negative. It's more minus 2.3. So this is minus 0.63. Since this is more negative, that means essentially this is more positive. Then if we have MgCl2 aqueous solution, we'll have an ion, we have Mg2 plus ions, Cl minus ions, and water. Now if we subject this to electrolysis, let's say, who do you think will reduce first, Mg2 plus or H2? There is a vast difference. This is minus 2.37, this is minus 0.63. H2O would tend to reduce. H2O would reduce and give H2 gas instead of Mg2 plus reducing and giving Mg solid. Then we can't extract Mg. So that is this electrolysis process. We are doing this, extract magnesium. This is how industrially in a big scale we extract magnesium. We can't do this now because we'll get H2 gas and Cl2 gas. That would be pointless. That is why we don't use MgCl2 aqueous, because in MgCl2 aqueous, water is the major constituent and that has more reduction potential than Mg2 plus, so that will reduce. So that's the explanation. Now if you write it in words, it would say that as H2O liquid, H2O water has higher reduction potential, minus 0.63, and Mg2 plus, this thing has minus 2.37, H2O tends to reduce more than Mg2 plus, thereby we will get H2 instead of magnesium. Hence we can't use MgCl2 aqueous in this extraction process. Right. Fifth one. Okay. Now they are saying in fifth question, this is they are basically asking to calculate the volume of Cl2 produced. Okay. They are saying 5.37 ampere current is passed through. So this is the power supply, right? Or you can say battery. So this produces the current. It gives current to this circuit. 5.37 ampere current is produced for 1 hour through this circuit, and after that the Cl2 gas is formed. Cl2 is forming, right? Where's the overall reaction? I erased it. Right. So the overall reaction is like this. Right. So when this electrolysis happens, this MgCl2 turns into Cl2 gas and Mg solid. That's what this equation signifies. So we get Cl2, right? One of the products. That Cl2 is collected and we have it stored in 300 Kelvin temperature and at 1 atmosphere, 1 atm pressure. That is equal to roughly, not equal to, that's roughly 1 into 10 to the power 5 Pascal, right? So calculate the volume produced. This is the question. So to do this, we have to use Faraday's law and Q equal IT. This is the question. I'll erase it and we'll start doing it. Okay. We all know Q equal IT formula. That is, the charge is equal to the current circulated into the amount of time that the current was circulated. So this would be in ampere current and time should be in seconds. That's the SI units. So in this equation we have to plug it in this like this, because actually ampere is coulomb per second. So when we multiply coulomb per second and second, we get charge. It is coulomb. So Q equal IT. Then we can get, if we plug it in, we get 5.37 amperes. The units are mass, it's chemistry, obviously. And the time is 1 hour. 1 hour is 1 into 60. We get 60 minutes into 60. Then we'll get seconds. So it's 3600 seconds, but 1 into 60 into 60. That's how we convert it. So you should multiply it, and when we multiply it, we'll get 19,300 coulomb. So it's a charge that was circulated throughout this 1 hour period. Okay. Now this charge, okay, we'll need this. We'll need this, right? This charge circulated 19,300 coulomb throughout this 1 hour. Who circulated it? Electrons, right? So we get electrons, the Cl minus gives the electron through oxidation. That electron goes like this. So the electron is the charge carrier. Electron is also the charge carrier, right? So we can find the mole of electrons by using the Faraday's equation, this equation. Mole of electron equal charge over Faraday's constant. They have given the Faraday's constant. If you look at the question, finally they have given Faraday's constant equal to 96,500 coulomb, right? So we can get the moles of electrons. This is the charge. So moles of electron equal 19,000. We have to write that here. Q over F equals to 19,300 coulomb over 96,500 coulomb per mole. Now coulomb gets cancelled, mole comes up, we get mole of electron is 1 over 5 or 0.2 mole. So moles of electrons. Now using stoichiometry, we can get moles of electron is to moles of Cl2 formed would be equal to 2 is to 1. Okay. Then moles of Cl2 formed would be 0.1 mole. Now we have this. Using this, can't we plug it into PV equal nRT for Cl2, and we know N, we know R, we know T, 300 Kelvin. So we know pressure 180. Can't we find the volume? We can. It's just a simple question. After this, I will erase this and we will find the answer for the volume of Cl2 produced. PV equal nRT for Cl2 gas. We get V equal nRT over P. 0.1 mole, the units are mass, chemistry, into 8.314 joule per Kelvin per mole, 300 Kelvin over 1 into 10 to the power 5 Pascal pressure. Now if we cancel this, simplify it, we will get 24.9 decimeter cube. So that's the answer, right? 24.9 decimeter cube of 24.9 decimeter cube of Cl2 was produced throughout this process, throughout this 1 hour process. So that is the question, electrochemistry part. It's such an easy question. So if we don't take electrochemistry, we will struggle to complete the chemistry paper within time, because electrochemistry, usually what we do is, whenever we get the paper, we don't even do the structure. We can do the structure, but if you take me, how I did the paper was, I skipped the structure, went directly to electrochemistry. That's how I do it. First we do the electrochemistry and the inorganic, the seventh question, then the organic question, which would be easy as well, 7, 8, and then we do the rest of the essay, and I do the structure final. Because even if we don't do the structure final, even if we do the structure final initially and do the essay, it's best to do it this way, because these two questions are such a time saving questions. We can finish electrochemistry. It's such an easy question. Once you get practiced, it's like you don't even have to think. It's they ask the same question over and over. They don't change the pattern, that is. So you can finish this question easily, quickly, and then the inorganic question next quickly, and then we can go to the organic and finish that. It's such a time saver. So we have, it's a must to choose this if you want to finish the paper within time without struggling. So it's best to practice this electrochemistry question over and over and do it. So that's one of my advices, and then that's it. Next up, let's see the seventh question, B part.